Good morning. This is section 4.1, commutative, associative, and distributive laws. So to start, we have the commutative law for addition, which is A plus B equals B plus A. That makes sense, right? So if we had, it's just saying like if we had 2 plus 3, that would be the same as 3 plus 2. And for the commutative law for multiplication, A times B is equivalent to B times A, which again, if you think about it, 2 times 3, we know is the same as 3 times 2. Okay, so go ahead and hit pause if you need to write those down. Otherwise, let's go ahead and move on. So example 1 is write an equivalent expression. Okay, and I have, looks like 5 of them here. So go ahead and hit pause and give all these a try. Let's see how many you can do. All right, so 3 plus x, that would be the same as x plus 3. 5 plus 3w, equivalent expression would be 3w plus 5. C times d, we could have d times c. A negative 7 times x, we could have x times negative 7. K times 8 plus 2. I'm going to actually do 2 of them here. So I'm going to switch, use the commutative law of addition. So I'm going to put the 2 first. So 2 plus, and then I'm going to use the commutative law for multiplication and change that k times 8 to 8k, which you didn't have to do both. Okay, you could have just done one or the other, and that would have been totally fine. Moving on, we have the associative law for addition. So what that says is that if we have A plus, and then the quantity in parentheses, B plus C, that is equivalent to the quantity A plus B in parentheses, then plus that C. And the associative law for multiplication is A times the quantity B times C is equivalent to the quantity A, B times C. The way that I remember these is the associative, like how just in normal everyday life we associate in groups, right? And parentheses mean grouping. So the associative law is the groups, the parentheses. The commutative law is where the pieces are just kind of moving around. And sometimes in class talk about like, well, what's moving around, like traffic. So you could think of like your commute. So your commute, the commutative law, that's when they're moving around. Associative, the groups, that's when you change up the grouping. Okay, so go ahead and see what you can do with these. I just have 4 of them. See if you can use our associative laws here. If you didn't write them down, you might want to hit pause. Use those associative laws to write an equivalent expression for those 4 problems. Go ahead and give them a try. All right, so we have x plus 2 in parentheses plus y. So let's go x plus 2 plus y and just change up the grouping to the second and third items because it was originally the first and second. Next, we have our w plus 9 plus k. And it was around items 2 and 3, kind of in the list. So I'll put them around 1 and 2. That would be equivalent. I have 3m. Let's put that in parentheses times the p. And finally, the w, let's group up the last 2 instead of the first 2. We get w, x, y. And finally, we have the distributive law, which is A times the quantity B plus C equals AB plus AC. When we go through and do it, I'll probably do this a lot where I'd show the A and I'll just draw a line to the B. So remember A times B, and I'll draw the line A times C. You'll see me do that a lot. A lot of people don't really believe this one. They don't think that it would work out. But just as a little side note here, so you don't have to write this part down. It's just a little side note. Like just say, for example, so I'm going to put the why this works. If I had 3 times 2 plus 5, we know how to do that based on our order of operations, right? We would do 3, and then 2 plus 5, we would get 7. 3 times 7, we would get 21. Now, what if we tried the distributive law? Now, it would be silly. It wouldn't I mean, mathematically it works, but you wouldn't typically do this distributive law in a problem like this because we have the order of operations, but sometimes you might have a variable in there. Like instead of the 2, it might be an x, and if you had the x plus 5, you wouldn't have that order of operations to be able to combine those if you didn't know what the x was. So to simplify, you would use a distributive property, okay? But just to illustrate that this works, I'm going to be silly and go ahead and show you that it is equivalent. So I'm going to go 3 times 2 is 6, and then plus 3 times 5 is 15, and 6 plus 15 equals 21. So again, you wouldn't actually do this. It was just me being silly showing you why it works so that you believe that it's true, okay? So we have a few of them here. Go ahead and try, well, let's do the first one together. No, I do want you to go ahead and try them. I think you can do it. Okay, try those first 3. Hit pause, come back when you're ready. Okay, so we have this 3, and we do 3 times x. What's 3 times x? 3x. And then 3 times a positive 5 is a positive 15. That's it. 5 times 2x. 5 times 2 is 10, right? So now we have 10x. 5 times a positive 4y is plus 20y. This one looks a little bit different, but we can still make it work. Let's take this 3 and apply it to the x first. So we have 3 times x is 3x. 3 times a negative 6 is a negative 18. So we write 3x minus 18. Okay, now go ahead and try these two. Try D and E and come back when you're ready. So now we have this whole negative 2 times 6 is a negative 12. And then we have this whole negative 2 times t is a minus 2t. Sometimes they'll ask for your answer in descending order, which means that you would put the exponent in, this one doesn't have an exponent, so you would put the variable first. So if we did have exponents, you would also do the exponents in descending order. So it's something squared minus that something, and then minus your constant. So what we do for that, and it's just kind of polite to do it in math, to put things with the variable first. Okay, so I'm going to move this around just to be polite, and that minus 2t, I'm going to bring that minus with it. So minus 2t minus 12. And then you'll see later on in the quarter when we start doing graphing that this is a very typical format. Okay, so it's going to be helpful for us later on. And finally, a 3 times 2t would be 6t. A 3 times a negative 5w would be a negative 15w. And 3 times 4, that 3 times positive 4 would be a positive 12. Example 4, we're going to kind of combine what we've been doing, okay? So we're going to have a kind of a grab bag here, a mixed grab bag of what we've been practicing. So simplify the expressions. Go ahead and try A and B. Let's see how you do. And a hint for on B is, do you see this negative sign out front? When you go to distribute, bring that negative with it, okay? So when you go to distribute, bring the negative. All right, go ahead and hit pause. Come back when you're ready. Okay, so we have this whole 4. I'm going to grab the whole thing just so you see. 4 times 2t would give me 8t. And 4 times negative 3 would be a negative 12. And then I still have that minus 7 on the end. What do you think? Am I done there? Is there anything I could do? I could do that negative 12 minus 7, right? So let's go ahead and do that just to simplify it completely. So we have an 8t, and negative 12 minus 7 is a negative 19. So our final answer is 8t minus 19. Next we have 5 minus 6 times the quantity x minus 2. So we're going to write down that 5. And in my hint, I said take that whole thing. So the whole negative 6 times x is going to be a minus 6x. And then that whole negative 6 times the negative 2 is a positive 12. Am I done? No, I can combine that 5 and 12, right? So like I mentioned earlier, I'm going to start with the variable. So I'm going to put that negative 6x out front. And then a positive 5 combined with a positive 12 is a positive 17. Okay, go ahead. Let's see. We're getting close here. Just a few more. Go ahead and try these three. And let's see. So for all of these, you're going to have to grab that negative. Okay, so that's kind of hard to remember to grab that negative. So that's why I put it in there. Go ahead. I'm going to change this one just a teensy bit. Make that a little bit bigger. There we go. Now I like it. Go ahead and try C, D, and E. Hit pause. Come back when you're ready. Okay, so for C, we're going to grab this entire negative 2, right? So I'm going to write down the 1 out front. So we have a 1 minus 2 times the quantity 5w plus 3k minus 6. So I wrote down my 1. Now I have a negative 2 times the 5w is a negative 10w. Negative 2 times the positive 3k is a negative 6k. Negative 2 times a negative 6 is a positive 12. Okay, now I'm going to rewrite these. You don't have to do it. Well, I mean, you do have to combine the 1 and the 12, right, to get to that 13. But as far as your order of your variables, I'm not too picky. Something that you might see as you go along in math is that we like to put things in alphabetical order. So in your book, you'll probably see it that way too. So I'm going to go and write it that way. So I'm going to put the K first because K comes before W in the alphabet. So we have a minus 6K, minus 10W. Just always bring that sign, whatever's up front, bring it with it. And then we have that positive 1 and a positive 12. I get positive 13. Now on this one, we have this whole negative 1 times an x as a negative x. Some people want to write include the 1, so they want to put a little 1 right here. Let me put it in. And if you need to do that, I'm okay with that, if that makes more sense to you. Hopefully in the next math class or two, we drop that just because it looks kind of silly. We don't really need to put it in there, but you can if you need to. A negative 1 times a negative 4y is a positive 4y. And finally, a negative 1 times a positive 7 is a negative 7. So for part E, I don't know if you noticed, but there was a little 1 in there. So if you need it, you can write it in, or you can just think of this negative being distributed to the x or to the 9. But a lot of people like to see that 1, so I'm going to go ahead and add it back in there just so I don't lose anybody. Okay, but you don't need it. So we have that 7, take that entire negative or negative 1 times x to then get that negative x. That negative 1 times a positive 9 would have a negative 9. So now let me combine my numbers here. So I've got the 7 and a negative 9 is what? That's a negative 2, right? So let me put the variable first, negative x, and then that negative 2. So negative x minus 2. And I just threw this one in here. Just one example since we do this so often. The 3 times the sum of the number and 2. So it's 3 times, and then what is it times? The sum of, and it's both the number and 2. So the sum of the number and 2, that would be the sum here, right? Adding x plus 2. But it's 3 times all of that. So some people just want to throw a 3 out front. That would not be the same thing. It's 3 times the entire sum of x plus 2. Okay, and then let's just go ahead and do it for extra practice. We would have 3x plus 6. All right, and that wraps up today. I hope you have a wonderful day. Bye.